Let's start taking a look at topic 7.3, evaluating sine and cosine using reference angles. I want you guys to pay close attention to how we're going to do this on these sheets, because this is how I'm going to need you to see you doing it on your test. You will be submitting work when you take your test. Previous Algebra 2 courses, of course, when we were in the classroom, you would not have a reference sheet. You would not be able to access the unit circle. You would be expected to have all of this memorized and known and be able to just recite it. So I'm going to want to see these procedures just to make sure we're mastering the standards. Now, when we're evaluating sine and cosine, we're looking at those coordinates that we had laid out in the unit circle. I have for you here a lovely handy-dandy reference angle chart. Angle in degrees, your angles in radians, your cosine value, your sine value. These were those ordered pairs that accompanied each of these angle measures, these reference angle measures. Now, keep in mind, we're on a coordinate plane. So if we're in quadrant 1, just like this is x and y, you also have cosine and sine. So in quadrant 1, cosine and sine are both positive. Quadrant 2, cosine is negative, sine is positive. Quadrant 3, both cosine and sine are negative. And in quadrant 4, cosine is positive and sine would be negative. Let's go ahead and jump in and do some of these problems. What are the cosine and sine of each angle? We're going to start out with radians. I've always found, I shouldn't say always, but in time, once I started to get more comfortable with radians, I noticed radians are a lot easier to use than degrees. So to determine your reference angle, it is as easy as this. Do you see how you have a 3 here in your denominator? That means the reference angle, you see that 3 there? Your reference angle is pi over 3. And if my reference angle is pi over 3, the value of cosine is 1/2. The value of sine is square root 3 over 2. So let's jump into that. So we know 1/2 square root 3 over 2. Oops. My reference angle I said was pi over 3. Now, I need to determine if these are positive or negative, which means I need to determine what quadrant it's in. So if I have 2 pi over 3, I know on my unit circle, this is 0 pi. This is pi over 2. Here is pi. Reference angles are always based off of the x-axis. So if I look over here, I want to write pi with 3 in the denominator. Well, that's 3 pi over 3. Remember, 3 pi over 3 is equivalent to pi. 3 over 3 is just 1. It's the same measurement. However, it helps me see where my angle is a lot easier. So if this is 3 pi over 3, that means I have to backtrack it up here. This would be 2 pi over 3. There's my angle in standard measure. Here's the terminal side of my angle, and I'm looking for these coordinates, 1/2 and square root 3 over 2. Well, if I'm in quadrant 2, notice cosine, those are your x values, are to the left of the y-axis, which makes them negative. But my sine is above the x-axis, which means it is positive. Let's go do another one. Number 2, 5 pi over 4. And again, we're in radians. All we need to do is look at the denominator. You see that 4? See the 4 right there? Pi over 4? That is your reference angle. Measurements of cosine and sine are both square root 2 over 2. These are the nice, easy ones to remember. So, my reference angle is pi over 4. I know I'm going to have a square root 2 over 2. Sine is going to be square root 2 over 2, but I need to determine if they're positive or negative. So let's find out what quadrant that's in. Again, we are at 0, pi over 2, and pi. Well, if I want to write pi with 4 in the denominator, that is 4 pi over 4. I'm looking for 5 pi over 4, which means I have to move another pi over 4 which would be right here. So there's my angle in standard position. This is the terminal side of my angle, and these ordered pairs are right here. Now, cosine, is that going to be positive or negative? Well, I'm to the left of the y-axis, so it is negative. Sine, I am underneath the y-axis, so that one is also negative. Number 3, this one is going to be a try it. It will be posted in Microsoft Teams underneath a Microsoft quiz form like you've been doing for daily attendance. Please give it a try, submit it. Once you submit it, go back to it, check your answers. Number 4, let's now work in degrees. Degrees take a little bit more work. So to find my reference angle, well, first thing I need to know is where is this? Where is this? Where is the terminal side of 315 degrees? So start out here at 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Well, 315 degrees is between 270 and 360 degrees, which means I'm in quadrant 4. So to determine my reference angle, now again, reference angles come from the x-axis, I need to know the angle measure over here to the x-axis to the terminal side of my 315 degrees. To do that, I'm going to take 360 degrees minus 315 degrees. Well, that tells me it is 45 degrees, which means the terminal side of my angle is right here. There's my initial side. Remember, counterclockwise is positive. So an angle measure, a reference angle of 45 degrees, if you look on your chart, it's the same as pi over 4, square root 2 over 2, both of them, both sine and cosine. If I'm in quadrant 4, cosine is positive, sine is negative. Number 5, let's do another one. 120 degrees. Okay, so here we go. 0 degrees, 90 degrees, 180 degrees. 120 degrees is between 180 and 90 degrees. So in other words, to find my reference angle, I need to take 180 degrees minus 120 degrees, which gives me 60 degrees. So that is the same, we just did this, 2 pi over 3. Right there. So we are in quadrant 2. And with a reference angle of 60 degrees, that is going to be, cosine is 1/2, sine is square root 3 over 2. And in quadrant 2, notice cosine is to the left of the y-axis, which means it is negative, and sine is above the x-axis, which means it is positive. Number 6, again, this one is going to be a try it. Look for that in your Microsoft Forms quiz.